Okay, so welcome to the course on analog and digital electronics. Okay, you have entered to the third semester of your graduation program, where you will find number of core subjects of electrical engineering now. Okay, so analog and digital electronics is one of the core subjects which you will find very much important while dealing with some electronic circuits. Okay, so talking about the prerequisites of this analog and digital electronics, we already have gone through the subject of basic electronics, right, where we have studied number of semiconductor devices. Okay, so we may find the use of these semiconductor devices in these analog circuits as well as digital circuits also, right. So talking about the subject, so basically, if I talk about the teaching scheme, then we will have total 4 lectures per week. Right? And talking about the tutorials, all the participants are requested to mute themselves. Okay, so we're talking about the tutorial. Now we will have 0 tutorial, and if we talk about the practicals, 2 hours per week practicals are there, and the total credit offered by the Gujarat Technological University is 5 for this particular subject. Okay, an examination scheme, as usual, we will have one end semester exam which is known as external component of the exam, comprises of 70 marks, right? And then there is progressive assessment which is known as mid semester component. It has total 30 marks, right? And this is about the theory portion, right? Similarly, we will have practical portion, and in that end semester exam, which is an external viva, it comprises of 30 marks, and internal viva, which is also known as progressive assessments, it will have 20 marks. Okay, so the total weightage of this particular subject is 150 per semester, right? So you need to score out of 150 for this particular subject. Okay, and as the name suggests, this particular subject is having 2 subjects in it. One is analog electronics and the other one is digital electronics. Okay, so if we talk about the syllabus point of view, then this entire subject is divided into 6 modules. Out of these 6 modules, 3 modules will be of analog electronics and another 3 modules will be of digital electronics, right? So we will talk about the module 1 to 3. In that we will study the concepts related to analog electronics, and remaining 3 modules, module 4 to 6, we will study the concepts and circuits related to digital electronics. Right? So out of these 4 lectures, 2 lectures will be of analog electronics and 2 lectures will be of digital electronics, which will be covered by 2 different faculties. So talking about analog electronics, that will be covered by me, and digital electronics will be covered by Darshni madam, Darshni Shukla madam. Okay, so I will be conducting 2 lectures per week, and Darshni ma'am will be conducting 2 lectures per week, right? So this is about the teaching scheme. Now talking about the outcomes of this particular subject. Okay, see, whenever one particular subject you came across this semester, we will be having some outcome of this particular subject, which are known as course outcomes, right? So you need to know what will be your course outcome. What does it mean? After completion of this course, what you will be able to do or what you should understand, right? So talking about the course outcome of this subject, we will have total 4 course outcomes. The first one is, after successful completion of this subject, you will be able to describe the functioning and selection of op-amp as per application. Okay. So you will find number of applications of this analog and digital electronics. Okay. So talking about analog electronics, we will find this operational amplifier. Okay. This is the, you can say, heart of analog electronics. You will find this operational amplifier in every analog circuit, right? So after completion of this particular subject, you will be able to describe the functioning and selection of op-amp as per our desired application. Okay, what kind of op-amps are available and how to select one particular op-amp for one particular applications, that will be decided by the designer, that is you. Then second course outcome is, you will be able to design and test testing of operational amplifier based circuits, right? So once we have gone through different modules of analog electronics, you will be able to design a particular circuit based on this operational amplifier for a different applications, right? And you will be able to test that particular circuit. Once we have designed the circuit, we have to test that circuit for a particular application, right? So after completion of these modules of analog electronics, we will be able to design as well as test the circuits, right? Then next 2 COs are pertaining to digital electronics. Okay, so what you will be able to do is, you will be able to design as well as implement combinational and sequential logic circuits, right? So whenever you will go through the basics of digital electronics, at that time you will find these 2 words. One is the combinational circuits and another one is sequential circuits. Okay, so whenever we go through the digital electronics, you will came to know that we will be available with 2 kinds of circuits. One is a circuit which do not store the memory, and one is the circuit which do store some memories, right? So whenever these memory elements are associated with the circuit, we will be dealing with the sequential circuit, and whenever memory elements are not associated with the circuits, we will be dealing with these combinational circuits. Okay, so after the end of the course, you will be able to design and implement both this combinational and sequential logic circuits, right? Then there is the last course outcome, which is CO4, is you will be able to describe the process of analog to digital conversion and digital to analog conversion, right? So once we move through the course, you will be understand why we require this analog to digital conversion as well as digital to analog conversion. Okay, it is necessary. We will see why it is necessary. So after the end of this particular course, you will be able to describe the entire process of this conversion, analog to digital conversion as well as digital to analog conversion. Okay, so these are the 4 course outcomes of this particular course, right? Analog and digital electronics. Now let us talk about the reference books. So university has defined some reference books for your purpose. Okay, so the first book which we are going to refer is microelectronic circuit. Microelectronic circuits, which is authored by A.S. Sedra and K.C. Smith. Okay, this is the first book which we are going to refer. Second book is microelectronics. Microelectronics by J. Millman. J. Millman and A. Grebel. Okay. Then third book which I refer to you for analog circuit is op-amps and linear integrated circuits. Linear integrated circuits. Okay, so this book is written by Ramakant A. Gaikwad, R. A. Gaikwad, a very famous book for analog electronics. Okay, so for our portion, if we talk about the syllabus according to GTU, then for module 1 and module 2, we are going to refer this book. Sorry, module 1, 2 and 3. For module 1, 2 and 3, you should refer this Ramakant Gaikwad book. And for module 4, 5 and 6, we have 2 other books, which is Digital Logic and Computer Design. Digital Logic and Computer Design by Maurice Mano. Mano. And another book is there which is authored by an Indian, which is known as Fundamentals of Digital Circuits. Fundamentals of Digital Circuits. Okay, this book is authored by Anand Kumar. Okay, so these 2 books are very good for digital electronics. That means module 4, 5 and 6 will be covered by this particular books. Okay, so if you have these 2 books in your library, then it will be very much beneficial to you. For analog electronics, I would prefer Ramakant Gaikwad, and for digital electronics, I would prefer this Maurice Mano or Anand Kumar. And these 2 books, microelectronic circuit as well as microelectronics, are also good, but it is authored by some foreign author, right? So the language would be somewhat of higher level compared to these 2 books, right? So these are the reference books which you need to prefer for the entire syllabus of analog and digital electronics. Okay, so this is about the introductory part of this particular subject. Now we will start with the actual things, that is analog electronics. Okay, so before we move on with the analog electronics, you must know what do you mean by analog electronics and how it is differing from digital electronics, right? So first question should arise in your mind is why we need to deal with these analog circuits, or what do you mean by analog signal, right? So whenever we talk about analog electronics and digital electronics, that means we are dealing with two kind of signal. One is analog signal and the another one is digital signal, right? So what do you mean by this analog signal, right? Now just take the example of current situation. I am talking to you, okay? So my voice, if I talk about my voice, then my voice is nothing but an analog signal, right? Or if you are listening to music, this is also one analog signal, okay? If I talk about the energy, that is also analog quantity. If I talk about the power, if we talk about the temperature, so all these quantities are analogous in nature, right? So the question is what kind of this analog signal looks like, okay? So generally when we talk about the analog signal, these analog signals are represented by some sinusoidal wave, or you can say this kind of wave, okay? So if I talk about the magnitude, this is the magnitude of signal, okay? So you can see as the time varies, then the magnitude of this particular signal is different. For this time t1 it is different, time t2 it is also different, then time t3 it is different, okay? But as you can see from this particular signal, this is continuous in nature. You can say there is no break in this particular signal, okay? So this kind of signals are known as analog signal, and the example of these analog signals are voice, music, energy, power, temperature, etc. And these kind of signals are readily available, okay? These are the naturally occurring signal, naturally coming signals. So talking about the analog signal now, analog signals are the naturally coming signals. Naturally coming signals, right? And they are continuous in nature, you can see, right? And these analog signals are analogous to natural or physical signal. They are analogous to natural or physical signals, right? So this is all about the analog signal which we are available with, right? Now talking about the electricity which is available at our home, okay? So if you try to draw the waveform of the voltage is available to you, then you will find one sinusoidal waveform like this, okay? If we are talking about the single phase supply, then we will get this kind of waveform, right? So this is analog in nature, this is continuous, you can see, though its magnitude changes with respect to time, but the signal is continuous, right? So these kind of signals are analog signals which are naturally available signals, or you can say these are the physical signals. Now comparing these analog signals with the digital one, okay? The second kind of signals which we are available is the digital signals. So what is the basic difference between this analog signal and digital signal? So talking about the digital signals, they are discrete in nature, right? What do you mean by discrete? Now suppose this sinusoidal wave shape is pertaining to analog signal, then digital signal means they are discrete in nature. So we will have some fixed value for certain amount of time like this, okay? So suppose this is my 0 value and this is 1 value, then for certain amount of time I will have this signal of constant, then it reduces to 0, then again it increases to 1, this reduces to 0, this increases to 1. So if I talk about the state of these digital signals, then we will have only two states. Either the signal will be 1 or signal will be 0. Okay. So talking about this signal equal to 1, suppose I am talking about the digital signal, then 1 means we are available with the 5 volt signal and 0 means we are available with the 0 volt signals, right? So this is what we get in digital circuits, right? Just give me 2 minutes. Okay, sorry for disturbance. So I was talking about this digital signals. Okay, so digital signals are discrete in nature. Okay, and talking about the continuity, they are not the continuous signal. As you can see from this waveform, right? The signal is positive for some time, then it reaches to 0, then again it becomes positive. That means 0, 0, 0 and 1. We are playing with the binary numbers in case of digital circuit. Okay, and these are not the naturally or physically occurring signal compared to analog. Okay, voice, music, energy, these are naturally coming signal, naturally occurring signal, and digital signals are not the natural one, right? So these are not naturally or physically occurring signals. So as I have told you that these are not the naturally or physically occurring signal, then there must be a question in your mind that why this digital signal exists then. We can understand for analog signal. Why? Because analogs are physically available everywhere, naturally available everywhere. And if these digital signals are not naturally available, then why it exists? Why we are generating? Okay, if it is not naturally occurring, then definitely we are generating that particular signal, right? So what is the reason that we are generating these digital signals? Okay, so the question, the answer is much predicted by you. If we are going to generate the digital signal, then there must be some advantage of the digital signal over the analog signals, right? This is the reason why we are generating digital signal. Yes, definitely there are certain advantages of these digital signals, and this is the reason why we are going to generate the digital signals. Okay, so let us have a look at the some of the advantages of this digital signal. Okay, so we are looking at the advantages of digital signal. That doesn't mean that analog signals are disadvantages. Okay, analog signal will also have some of its advantages. Okay, so we are also going to see the advantages of analog signals too, right? So first look at the advantages of digital signal, and then we will move on to the advantages of analog signals. Okay, so the first advantage of this digital signals are they are very easy to process. they are easy to process, right? So how they are easy to process? Let us try to understand. Okay. So whenever you will talk about the digital electronics, we will be available with different logic gates, right? Like AND gate, NAND gate, NOT gate, etc. So different logic gates are available, right? Now let us say I am available with one typical logic gate. Okay, this is my AND gate, which is having two input and one output. Okay. Similarly, I will have OR gate, which is again having two input and one output. Right? Or anything, we will have some multiplication circuit like this, where we are going to provide two inputs, say A and B over here. Similarly, here also we will have two inputs, A and B. Okay, and we may also have adder circuits. Okay, let us say one full adder circuit are there. Okay, if you do not understand this point, then do not worry, we all are going to cover these particular circuits. Okay, so these are my digital circuits. Okay, all these four circuits are digital circuits, and the function of each and every circuit is different. Now if I talk about the first circuit, right, then this is an AND gate. Okay, so basically the function of AND gate is to multiply the two input signals. Okay, so whenever I give input at this terminal A and this terminal B, these two signals will get multiplied at the output. Okay, so my output would be A into B. Similarly, here this is OR gate, which will add the two input. Okay, so output would be A plus B. Okay, and here output would be A cross B. Similarly, to full adder circuit, if we provide two inputs, then some of the bits will be there, and there is one more output which is known as carry. Okay, we will see what do you mean by carry, what do you mean by sum in the later sessions. Okay, so now see, I am available with two inputs, input A and input B. I want to add these two inputs, so simpler, I will use this particular gate circuit, one logic gate OR gate, and it will give us the output of A plus B. Similarly here, if I want to multiply the two inputs A and B, then I will use this AND gate, which will give us the output A dot B. Right. Similarly, if I want to add this two bit A into B, then this sum point will give us the summation of the two input signals of A and B. Okay. So these are the circuits which we are going to use in case of digital circuits, right? And you can see they are very easy to process, nothing you need to do. Okay, just we need to take one logic gate, you need to apply two inputs A and B, and corresponding outputs will be achieved by us. Okay, so these digital signals are very easy to process. Okay, any digital circuit can easily obtain the product. If I talk about this particular circuit, A cross B, so we are getting the product of input A and input B. Okay, so this digital circuit can easily obtain the product, right? So these are our particular case. The first advantage which is offered by digital circuits, and that is why we are going to convert analog signal into digital one, and then we will process the signal. Okay, second advantage of digital signal is they offer more immunity to noise. Okay, they offer more immunity to noise. Okay, so the question should arise in your mind, what do you mean by noise? Okay, so noise are the electrical signals which are not desired by us. Okay, so suppose I am talking about the sinusoidal signal which is available to us, right? One sine wave is there like this. Okay, so you can see this is a pure sine wave. Okay, but actually this pure sine wave is not existing. If you actually draw, we will get this kind of waveform. Okay, you will always have some distortion in the waveform, and that distortion is nothing but because of the noise. Okay, so noise creates some disturbance in the actual signal. Okay, so talking about the digital signals now, they are more immune to the noise, such that your output which we are getting of out of digital circuits, these are noise free output. Okay, now let us consider the case of analog electronics over here first. Okay, so I have one analog circuit which comprises of one operational amplifier, right? So this is the inverting terminal of operational amplifier, to which I am providing one signal. Okay, so this is my input signal V in. Okay, this is one resistor, and here is what we are getting output voltage. Okay, this is my feedback resistance RF, and non-inverting terminal is grounded. Okay, so this is one typical circuit which will give us some output. Okay, so now here I am providing some input, right? At this instant I am providing some input, and here I am getting some output, right? So if I talk about this output, then output is given by minus RF by R1 into V in. Okay, so this much output voltage we are getting out of this particular signal. Okay, now consider RF is equal to 1 kilo ohm and R1 is also equal to 1 kilo ohm. Okay, so what will happen? This ratio RF by R1 will become 1. So now my output voltage will be equal to input voltage. Okay, so consider one input voltage of 5 volt. Then what will be the output voltage in this case? Output voltage V0 would be equal to minus 5 volt, right? Now I change my input voltage to 3.5 volt. Then what is going to happen to output voltage? Output voltage is also 3.5 minus 3.5 volt. Okay, so this is the way in which we are getting my output voltages. Okay, now because of this noise, what will happen, as you have discussed over here, consider this sinusoidal waveform. Okay, this sinusoidal waveform is of 5 volt, but because of the noise, this waveform is deteriorated and it will give us only 4.5 volt in place of 5 volt. Okay, so what happens, my input actually becomes 4.5 volt, not the 5 volt, right? And this is the reason why output voltage we are getting is minus 4.5 volt, not 5 volt. Okay, your actual output, our target output is 5 volt only, but because of this noise, the output becomes minus 4.5 volt. Okay, so this is the effect of noise on the output circuitry of this analog circuit. Okay, now let us say we are available with the digital circuit. Okay, so I am going to use one AND gate over here. Okay, so this is my AND gate. Right. Now what I am doing, I am providing some input. Okay, say these two inputs are there. Okay, 1 and 1. Okay, this is my input A, this is my input B, and what will be the output? Output will be equal to A dot B. Okay, so 1 in 1 dot 1 will become 1, so our output would be 1, like this. Okay, both the inputs are having 1. So 1 1 will give you output of 1. And what is 1 pertaining to? 1 pertaining to 5 volt as we have discussed, and 0 pertaining to 0 volt. Okay. So here if you measure the magnitude of output, it should be 5 volt, right? Now consider these two inputs have been given as 5 volt. Out of these two inputs, suppose because of the noise my input B is not the 5 volt but it will be 4 volt only. In that case, what should be the output? Output will be still 5 volt, right? Because this logic gate will consider only two input. Either your input will be 1 or your input will be 0. Okay. So it does not matter if we are providing this kind of waveform or this kind of waveform. Okay, this is pertaining to 4 volt and this is pertaining to 5 volt, right? So both these inputs will be considered as 1 for this by this AND gate. Okay, and that is the reason it will give us the output in case of 1 other than 0. Okay, so now see the difference. Our target output was 5 volt, but because of the noise at the input level, the analog circuit will give us the output of minus 4.5 volt, whereas the digital circuit will give us output of 5 volt, which is the noise free output, right? So here we are getting noise free output in case of digital circuit. Okay, so this is another advantage of digital circuit, that it provides more immunity to the noise, right? So here no amount of imperfection is transmitted to the output. Even if there are some errors at the input, they will be corrected at the output. That is what is done in this particular case, right? No amount of imperfection is transmitted to the output, even if there are some errors, there are some errors at input, they will be corrected at the output. Okay, so this was our second advantage of digital signals. Then the third advantage are they are easily reproducible. They are easily reproducible, right? Now what does it mean, right? Let us try to take one particular digital signal. Okay, so I have this digital signal. I am having 0 value, 1 value, then again 0 value, 1 value, 0 value and 1 value. Okay, so this signal is comprising of this is 0, this is 1, this is 0, this is 0, 1, 0, 1 and 0. Okay, this is my digital signal, and on the counterpart I will have one analog signal. Okay, say this is my analog signal, right? Now what do you mean by reproducibility? If you are able to generate the same signal one more time, then you can say this is the reproducible signal. Okay, so in case of digital signal, definitely you will be achieve the same signal which we have produced earlier, right? Like this. Okay, this is the pattern of the signal. So I will have 0 value, 1 value, then again 0 0 1 0 1 and 0. Okay, so you can see, okay, the digital signals are exactly reproducible. But suppose I want to reproduce this signal, analog signal, then it is not possible for me to exactly generate this signal again. Okay, there will be some change in this signal like this. Okay, so if you compare these two signals, these are not the copy of the previous signal. Okay, so it will be very much harder for us to generate the same signal in case of analog electronics, while it is very much easier for us to generate the same signal in case of digital electronics. Okay, so the signals are very easily reproducible in case of digital electronics. Okay, so you may find number of applications where we are going to use this digital electronic signals. Okay, say for example of digital circuits are first in microprocessors or microcontrollers. Second, you may find the application of digital circuit in encoders or in memory elements, right? All of we are using the mobile where we have some memory, right? So this memory will be in form of digital signals only. Okay, so these are the typical, some of the applications, not the all, some of the applications of digital circuits where we are processing the digital signal because of these advantages. The advantage is they are very easy to process, they are more immune to noise, and they are very easily reproducible. Okay, so because of these advantages offered by digital signals, one may find the applications of digital signal in number of circuits. Okay, so we have now two particular systems, two typical systems. If we talk about the systems, then we have two systems. One is analog system and another one is digital system. Okay, so one is analog system and the other one is digital system, right? So as we know, analog system is very well known to us. So we will have a continuous signal like this, right? And in case of digital signal, we are having discrete signal. Now see how it is sampled. Okay, the question is, if we have the analog signal, then how we are converting this analog signal to digital signal. Okay, so we are doing sampling of these signals. Okay, so the analog signal is sampled into the digital one. How? Let us see. See, if you look at this analog signal, then you can see we are having number of magnitudes with respect to time, right? So what I am doing, I am sampling these signals. Okay, let us say this is my first signal. Okay, so let us try to draw this signal. Then this is my second signal, second sample. Okay, so I am taking this second sample. Then this is our third sample which I am taking over here. Similarly, fourth sample, fifth sample, sixth sample, then the samples in reverse direction like this. Okay, so what I have done, if you look back, you will find one sinusoidal wave only in these particular cases, but I have divided this sinusoidal wave into number of samples like this. Okay, so now it becomes discrete samples, discrete signals, and this is how analog signal is being converted into digital signals. Okay, So we have these two signals now. One is the analog signal, another one is the digital signal, right? So the question is, which one to choose? If I am available with the analog signal, if I am available with the digital signal, then the question should arise in your mind that which one I need to choose. Okay, and definitely you will choose the digital one because we have seen number of advantages. Okay, so according to these advantages, everything everything should be digital, right? Because they are very easy to process, they are more immune to noise, they are very easily reproducible. So each and every signal must be converted into digital one, right? This is what our answer should be. But unfortunately, it is not possible. Okay? So it is not possible that every analog signal will be converted into digital one. Why? Because there are some problems of digital signals also. Okay, that means we are available with some advantages of analog signal, right? So let us try to see these advantages of digital signal, sorry, advantages of analog signals. Analog signals or systems. Okay, so the first and foremost advantage of analog system is this is the physical signal which is available. Okay, naturally coming signal. So we did not need to convert this signal to any other form. Okay, so this is the advantage. This is the physical signal which is already available. Okay, so we need not to convert this signal to any other form. This is its best advantage. Second, we will be able to process the analog to analog signal directly and it will be much faster. Okay, so the second advantage is analog to analog processing will be done directly and this process is much faster. See, we are doing the same process in case of digital one over here. Okay, we are multiplying the signal, we are adding the signal, but in this case what we need to do, as digital signals are not available physically, we need to convert our analog signal into digital one. So we will require one converter over here and then this process will be done. Then again this digital signal needs to be converted into analog. Okay, so it will take some time, but if we are able to process the analog signals only, then it will be much faster, right? Say I am considering the same case. I have one input A, I have one input B, and I want to take the product of these two inputs A and B. Okay, so it will be much faster if we can process these two signals to analog signals directly. Okay, so the processing time will be reduced in case we are dealing with analog systems only, right? Then the analog signal processing, analog signal processing has the ability to provide a wider bandwidth and larger dynamic range. Larger dynamic range. Okay. So what do you mean by bandwidth? Bandwidth is nothing but the range of frequencies that can be handled by a system. Okay. So these are the advantages of analog systems, and that is why analog circuits also exist. Okay, because some circuits are there which cannot be processed digitally, and that is the reason why still we are using these analog signals, right? So we have one analog signal and we are going to digitize this analog signal to digital one, right? So the processing has been done, right? Now talking about the occupancy of these analog signals and digital signals. Okay, so talking about on an average 50% to 90% of the circuits which are existing into the market are digital circuits. Okay, you can see if 100% circuits, electronic circuits are available into the market, then out of these 100% circuits, 50 to 90% of the circuits will be digital circuits, and only 10 to 50% circuits of circuits into the market are analog circuits. Okay, but these 10 to 50% circuits, whenever we are going to design these 10 to 50% circuits, it will take 90% of design time. 90% of design time. Okay, so you should understand that designing analog circuits is much more challenging. Okay, so why this analog design is more challenging than digital signal, right? See, first thing, if we talk about the analog domain, then in analog domain no standard signal is available. Okay, in case of digital circuit, standard signal is available, either your signal will be 0 or it will be 1, but in analog domain no standard signals are available. So this is the first difficulty. Second, analog circuits are more susceptible to noise, to supply variations and temperature, right? So this is also one of the challenges. Whenever we find any noise, then we have seen that output is affected with the presence of noise, right? So they are more susceptible to noise. This is the second challenge. Third, no standard analog circuits are available. Okay, in case of digital circuit, whenever one particular digital circuit is prepared, the same digital circuit can be used for another application, right? But in case of analog circuit, no such standard circuits are present. Okay, each and every component has to be designed individually in case of analog circuits. Okay, and you need to understand the internal working of each and every circuit of analog circuits. Okay, so talking about this analog circuit, each new analog circuit is state of the art. Okay, for one typical application we are going to design one analog circuit, and that analog circuit cannot be used for another purpose. Okay, so design of analog circuit is definitely challenging, but if we talk about the end product, then end product will be very much simple, right? So these two are the typical outputs of analog circuits. Though analog design is very much challenging compared to digital circuit design, but whatever new circuit we have designed, it will be the state of the art, and it will be very much simple in case of analog circuits. And that is the reason why analog electronics still exist. Okay, if we compare the advantages of digital circuits with analog circuits, then definitely digital circuit has more advantages, but still we are using this, or we are designing these analog circuits because of certain advantages that are offered by analog circuits also. Okay, because all the signals which is available naturally, that is in the form of analog only, and we will take the advantage of that particular signal, and we are going to design different analog circuits, which itself is state of the art circuits, right? So this is all about the digital electronics and analog electronics. Okay, so now you must understand the difference between the digital circuit and analog circuits. So from the next lecture we will start with the analog circuit, and ma'am will start with the digital circuits. Okay, I hope you are clear about the difference between the analog signal and digital signal by the end of this particular session. Okay, so we will stop here. In the next lecture, we will start with the first module of the syllabus, that is Introduction to Analog Circuits, or Introduction to Operational Amplifiers. Right? Yes, please. Anyone having any questions, then you can ask.